Functions, Lesson 4, Multiple Representations of Functions. Consider the function g of x equals negative 3 halves x plus 2. That is the equation. We're going to create a table and a graph from that equation. First, we can actually do either one first, but I'm going to do the graph first. The reason I do the graph first is we have a nice, really quick method for creating the graph using the slope of negative 3 halves and the y-intercept of 2. So I start with the y-intercept of 2 on my graph, which is just up 2 from the origin. And then I do my slope of negative 3 halves. It's going to be down 3 over 2, down 3 over 2 again, until I run out of room. I can also go up 3 and back 2. Looks like I can do it once. And there my graph is nearly complete. I actually should put some numbers on it, just labeling my axes a little bit here. Okay. Now for the table can be done just by picking points off of the graph and just putting them into the table. It could be done another way as well. For example, we know the y-intercept is 2, so we could put in 0, 2. The slope being negative 3 halves means that the y is going to increase by 3 or decrease by 3, while the x goes down by 2. That'll give us a slope of negative 3 halves, which that pattern right there is exactly what happens here anyway. Because if we go up 2 here on the x's and down 3 on the y's, we do end up getting exactly what we see over here. This is 2, negative 1, this is 4, negative 4, and this is 6, negative 7. Okay, let's look at another example. This time we're starting with the table. We can create the equation or the graph. Creating the equation is not too difficult. We just need to know the slope and the intercept. The slope is, well, it looks like the outputs increase by 1, going from negative 5 to negative 4. The inputs increase by 2, going from negative 2 to 0, giving us a slope of 1/2. The y-intercept is found by finding the input of 0, and it's the number that is the output. That's the y-intercept. With that information, we are ready to write our equation. Y equals 1/2 x minus 4, putting the slope in front of x and the intercept kind of out as the constant term on that side. This also could be written in function notation, which would look something like this, just changing the y with maybe an f of x. Now for the graph could be created a couple of ways. We could plot the points from the table. When we were first creating graphs, that's actually what we did. We would create the table and then we would plot points. Or we can draw the graph using the equation that we've found, which I think is what I'm going to demonstrate here. So on my equation, the y-intercept is negative 4. I'm going to make the plot that point on my graph. The slope is 1/2. That's up 1 over 2, up 1 over 2, repeating until I run out of room in both directions, and I get my graph. Okay, next example, we're going to start having a graph. We're going to create the equation and the table. Well, let's go ahead and create the table first here. We've got these 3 points which we can put into the table. This point here is negative 5, negative 8. This point here is 0, negative 6. And this point is 5, negative 4. Now, using pattern recognition, which one comes next? Negative 5, 0, 5. The next one's going to be 10. Negative 8, negative 6, negative 4. The next one's going to be negative 2. Now, for the equation, we need to know the slope and intercept. The intercept, of course, is negative 6. We can see that here on the graph or here in the table. The slope if we find the slope from the graph, we would do a triangle, rise 2, run 5. That's going to be a slope of 2/5, up 2 over 5, rise 2, run 5, giving us an equation, y equals 2/5 x minus 6. And then that's the equation. Let's go ahead with this one. We were given the equation. We're going to create the table and the graph. I'm going to create the graph first because we have a really good process that we've learned that we can use to create graphs. Just going to do some labeling here real quick. Okay, in the equation we have the y-intercept of minus 2, so negative 2 is the intercept. And then the slope is 3, which we want to treat as a fraction, 3 over 1. From here we go up 3 and over 1 and repeat it until we run out of room. It looks like we can do it once in the reverse direction, going down 3, back 1, and we get our line. Now we did end up with 4 points here. I'm going to put those 4 points in the table. This first point down here is negative 1, negative 5. This point is 0, negative 2. This one is 1, 1. And this one is 2, 4. And I need to label this x, and the output should be labeled with g of x. And then I've got my table complete. All right, let's look at another example. This time we're starting with a table. We need to create the graph and the equation. I'm going to start with the equation. The y-intercept, of course, is 4. The slope, it looks like the y's decreased by 3, while the x's increased by 2. So that gives us a slope of negative 3/2. So this is f of x. That's just what it's called here. F of x is negative 3/2 x plus 4. And then for the graph, I need to create an x-axis and a y-axis. And label these 2, 4, 6, and then on the y-axis going down, negative 2, negative 4, negative 6. On the x-axis going to the right, counting up, and to the left we count down. And then we can create our graph. Our y-intercept is negative 4. Nope, that's not negative 4, that's positive 4. So that's going to be up here. Our slope is negative 3/2. That's down 3 over 2 from the intercept that I just did. Down 3 over 2 again, and again till I run out of room. It doesn't look like it can do it in the reverse direction because there's no room for it. So I go ahead and connect the points I've created. And there's the equation and graph for that table. Okay, this time we're starting with a graph. We're going to create a table and an equation. Say we create the table first. We just take points from this. We've got 0, negative 30. This one is at 3, negative 20. This one right here is at 6, negative 10. And this one is at 9, 0. So we've created a decent table. Now for the equation, we need to just find slope and intercept. Intercept, of course, is negative 30. It's just right here. The slope, got to be careful here. The rise is 10 because I'm going from negative 20 to negative 10. The run is 3 because I'm going from 3 over to 6. So that gives us a slope of rise 10, run 3, 10/3. Oh, I haven't decided whether to call this. Well, let's give it in function notation. Let's make this b of x. So b of x equals 10/3 x minus 30. Now, by the way, if you're confused about why I chose b of x, it's just a letter that came to mind. We can use any letter really we want here. I just chose to use b. I could have even just written y equals. Okay, we're also going to do a little bit of comparison. In fact, our next lessons will get into doing comparisons more. All right, you need to realize what rate of change is. So which line has the greater rate of change? Remember, rate of change is the change in input compared to change in output, or the rise over the run. It's essentially the slope. So the rate of change for A, line A, is 3. And the rate of change for line B, we're going to have to use rise over run to find it. The rate of change for line B is 3/2, while the rate of change for line A is 3. So which one has a greater rate of change? It would be line A, because 3 is greater than 3/2. Which person has a greater wage? Here, we can find Jethro's by realizing he increases $27 for 3 additional hours of work. So $27 for 3 hours. Jethro is making $9 an hour. Now for Gorby delivers car parts for 5 hours and is paid $48. For this one, it's basically like finding unit rate that we did in 7th grade. 48 divided by 5 is 9.6. So Gorby is making $9.60 an hour. And Joey, there's a couple of lattice points drawn here. This one's drawn at 2.5. I guess we could use that. That's up 20 over 2.5. So he makes $20 in 2.5 hours, which comes out to be $8 per hour. So who has the greater wage is going to be Gorby. Okay, which person has a car with better gas mileage? Here we've got Jeremiah, Sammy, and Lorena. Jeremiah goes 60 miles in 2.5 hours, or 120 miles in 5 hours. Let's do that one, it's got whole numbers. 120 miles in 5 hours is 24 miles per gallon. I said hours, I meant to be saying gallons on that. Jeremiah went 120 miles with 5 gallons. Now Sammy goes 300 miles on 12 gallons of fuel, which is 25 miles per gallon. And Lorena, when she increases the amount of gas by 4 gallons, the distance traveled increases by 84, making her rate of consumption of gas or fuel economy 21 miles per gallon. So which car gets the better gas mileage? It's going to be Sammy at 25 miles per gallon. Okay, a little bit of a preview of the assignment that you should be working on with this. Number 1, you're given an equation, you need to create the table and the graph like we did. Number 2, you're given the table, create the equation and the graph. Number 3, you're solving an equation. This is like what we did in Unit 1. Number 4 is like a problem from Unit 2. I give you the side length of a square and ask you what the area of the square will be after it is rotated. Number 5, I'm giving you 3 functions, f of x, g of x, and h of x, and asking you to compute f of 3, g of -1, and h of -2. Tell me true or false if h of 4 is bigger than g of 4. Number 6 is a situation problem where you have a plant, you buy it, it's 3 inches tall, it's going to grow 2 inches per month. You're going to create a table, a graph, and an equation, and then part D, you get to interpret what the y-intercept means. Number 7 and 8, you're creating functions based on given criteria. For example, on 7, the function you create has to have an output of 6 when you input 2. And on number 8, you need to create a function that has a greater rate of change than j of x, if j of x is 10x plus 15.